A photograph shows an agronomist and a farmer in a soybean field inspecting a plant. Figure 8. 1. Depending on the competition and prices offered, a soybean farmer may choose to grow a different crop. Credit. Modification, Agronomist and Farmer Inspecting Weeds by United Soybean Board/Flickr, CC by 20. Chapter Objectives. In this chapter, you will learn about perfect competition and why it matters, how perfectly competitive firms make output decisions, entry and exit decisions in the long run, efficiency in perfectly competitive markets. Bring it home a dime a dozen. When you were younger, did you babysit, deliver papers, or mow the lawn for money? If so, you face stiff competition from many other competitors who offered identical services. There was nothing to stop others from also offering their services. All of you charged the going rate. If you tried to charge more, your customers would simply buy from someone else. These conditions are very similar to the conditions agricultural growers face. Growing a crop may be more difficult to start than a babysitting or lawn mowing service, but growers face the same fierce competition. In the grand scale of world agriculture, farmers face competition from thousands of others because they sell an identical product. After all, winter wheat is winter wheat, but if they find it hard to make money with that crop, it is relatively easy for farmers to leave the marketplace for another crop. In this case, they do not sell the family farm, they switch crops. Take the case of the upper Midwest region of the United States. For many generations, the area was called King Wheat. According to the United States Department of Agriculture National Agricultural Statistics Service, statistics by state, in 1997, 6 million acres of wheat and 780,000 acres of corn were planted in North Dakota. In the intervening 25 or so years, has the mix of crops changed? Since it is relatively easy to switch crops, did farmers change what they planted in response to changes in relative crop prices? We will find out at chapter's end. In the meantime, let's consider the topic of this chapter, the perfectly competitive market. This is a market in which entry and exit are relatively easy and competitors are a dime a dozen. Most businesses face two realities. No one is required to buy their products, and even customers who might want those products may buy from other businesses instead. Firms that operate in perfectly competitive markets face this reality. In this chapter, you will learn how such firms make decisions about how much to produce, how much profit they make, whether to stay in business or not, and many others. Industries differ from one another in terms of how many sellers there are in a specific market, how easy or difficult it is for a new firm to enter, and the type of products that they sell. Economists refer to this as an industry's market structure. In this chapter, we focus on perfect competition. However, in other chapters we will examine other industry types, monopoly and monopolistic competition, and oligopoly. Learning objectives. By the end of this section, you will be able to explain the characteristics of a perfectly competitive market, discuss how perfectly competitive firms react in the short run, and in the long run firms are in perfect competition when the following conditions occur. 1. Many firms produce identical products. 2. Many buyers are available to buy the product, and many sellers are available to sell the product. 3. Sellers and buyers have all relevant information to make rational decisions about the product that they are buying and selling. And 4. Firms can enter and leave the market without any restrictions. In other words, there is free entry and exit into and out of the market. A perfectly competitive firm is known as a price taker because the pressure of competing firms forces it to accept the prevailing equilibrium price in the market. If a firm in a perfectly competitive market raises the price of its product by so much as a penny, it will lose all of its sales to competitors. When a wheat grower, as we discussed in the Bring It Home feature, wants to know the going price of wheat, they have to check on the computer or listen to the radio. Supply and demand in the entire market solely determine the market price, not the individual farmer. A perfectly competitive firm must be a very small player in the overall market, so that it can increase or decrease output without noticeably affecting the overall quantity supplied and price in the market. A perfectly competitive market is a hypothetical extreme. However, producers in a number of industries do face many competitor firms selling highly similar goods, in which case they must often act as price takers. Economists often use agricultural markets as an example. The same crops that different farmers grow are largely interchangeable. According to the United States Department of Agriculture monthly reports, in December 2021, U.S. corn farmers received an average of $5.47 per bushel. A corn farmer who attempted to sell at $6 per bushel would not have found any buyers. A perfectly competitive firm will not sell below the equilibrium price either. Why should they when they can sell all they want at the higher price? Other examples of agricultural markets that operate in close to perfectly competitive markets are small roadside produce markets and small organic farmers. Link it up. Visit this website that reveals the current value of various commodities. This chapter examines how profit-seeking firms decide how much to produce in perfectly competitive markets. Such firms will analyze their costs as we discussed in the chapter on production, costs, and industry structure. In the short run, the perfectly competitive firm will seek the quantity of output where profits are highest, or if profits are not possible, where losses are lowest. In the long run, positive economic profits will attract competition as other firms enter the market. Economic losses will cause firms to exit the market. Ultimately, perfectly competitive markets will attain long-run equilibrium when no new firms want to enter the market and existing firms do not want to leave the market, as economic profits have been driven down to zero. Learning objectives. By the end of this section, you will be able to calculate profits by comparing total revenue and total cost, identify profits and losses with the average cost curve, explain the shutdown point, determine the price at which a firm should continue producing in the short run. A perfectly competitive firm has only one major decision to make, namely, what quantity to produce. To understand this, consider a different way of writing out the basic definition of profit. Profit equals total revenue minus total cost equals price, quantity produced, minus average cost, quantity produced. Since a perfectly competitive firm must accept the price for its output as determined by the product's market demand and supply, it cannot choose the price it charges. This is already determined in the profit equation, and so the perfectly competitive firm can sell any number of units at exactly the same price. It implies that the firm faces a perfectly elastic demand curve for its product. Buyers are willing to buy any number of units of output from the firm at the market price. When the perfectly competitive firm chooses what quantity to produce, then this quantity, along with the prices prevailing in the market for output and inputs, will determine the firm's total revenue, total costs, and ultimately, level of profits. Determining the highest profit by comparing total revenue and total cost, a perfectly competitive firm can sell as large a quantity as it wishes, as long as it accepts the prevailing market price. The formula above shows that total revenue depends on the quantity sold and the price charged. If the firm sells a higher quantity of output, then total revenue will increase. If the market price of the product increases, then total revenue also increases whatever the quantity of output sold. As an example of how a perfectly competitive firm decides what quantity to produce, consider the case of a small farmer who produces raspberries and sells them frozen for $4 per pack. Sales of one pack of raspberries will bring in $4, $2 packs will be $8, $3 packs will be $12, and so on. If, for example, the price of frozen raspberries doubles to $8 per pack, then sales of one pack of raspberries will be $8, $2 packs will be $16, $3 packs will be $24, and so on. Table 8. 1 shows total revenue and total costs for the raspberry farm. These data also appear in Figure 8.2. The horizontal axis shows the quantity of frozen raspberries produced in packs. The vertical axis shows both total revenue and total costs, measured in dollars. The total cost curve intersects with the vertical axis at a value that shows the level of fixed costs, and then slopes upward. All these cost curves follow the same characteristics as the curves that we covered in the production, costs, and industry structure chapter. The graph shows that firms will incur a loss if the total cost is higher than the total revenue. The x-axis is the quantity of raspberry packs. The y-axis is the total cost total revenue. The description of the graph is located in the paragraph below the table, Figure 8. Total cost and total revenue at the raspberry farm. Total revenue for a perfectly competitive firm is a straight line sloping up. The slope is equal to the price of the good. Total cost also slopes up, but with some curvature. At higher levels of output, total cost begins to slope upward more steeply because of diminishing marginal returns. The maximum profit will occur at the quantity, where the difference between total revenue and total cost is largest. Quantity Q, total cost TC, total revenue TR. Profit $0.62 $0 minus $62 $10 $90 $40 minus $50 $20 $110 $80 minus $30 $30 $126 $120 minus $640 $138 $160 $2250 $150 $200 $50 $60 $165 $240 $75 $70 $190 $280 $90 $80 $230 $320 $90 $90 $296 $360 $64 $100 $400 $400 0 $110 $550 $440 minus $110 $127 $480 minus $235. Table 8. 1. Total cost and total revenue at the raspberry farm based on its total revenue and total cost curves. A perfectly competitive firm like the raspberry farm can calculate the quantity of output that will provide the highest level of profit. At any given quantity, total revenue minus total cost will equal profit. One way to determine the most profitable quantity to produce is to see at what quantity total revenue exceeds total cost by the largest amount. Figure 8.2 shows total revenue, total cost, and profit using the data from Table 8.1. The vertical gap between total revenue and total cost is profit. For example, at Q equals 60, TR equals 240 and TC equals 165. The difference is 75, which is the height of the profit curve at that output level. The firm doesn't make a profit at every level of output. In this example, total costs will exceed total revenues at output levels from 0 to approximately 30, and so over this range of output, the firm will be making losses. At output levels from 40 to 100, total revenues exceed total costs, so the firm is earning profits. However, at any output greater than 100, total costs again exceed total revenues and the firm is making increasing losses. Total profits appear in the final column of Table 8.1. Maximum profit occurs at an output between 70 and 80, when profit equals $90. A higher price would mean that total revenue would be higher for every quantity sold. A lower price would mean that total revenue would be lower for every quantity sold. What happens if the price drops low enough so that the total revenue line is completely below the total cost curve? That is, at every level of output, total costs are higher than total revenues. In this instance, the best the firm can do is to suffer losses. However, a profit-maximizing firm will prefer the quantity of output where total revenues come closest to total costs, and thus where the losses are smallest. Later we will see that sometimes it will make sense for the firm to close, rather than stay in operation producing output. Comparing marginal revenue and marginal costs, the approach that we described in the previous section, using total revenue and total cost, is not the only approach to determining the profit-maximizing level of output. In this section, we provide an alternative approach which uses marginal revenue and marginal cost. Firms often do not have the necessary data they need to draw a complete total cost curve for all levels of production. They cannot be sure of what total costs would look like if they, say, doubled production or cut production in half, because they have not tried it. Instead, firms experiment. They produce a slightly greater or lower quantity and observe how it affects profits. In economic terms, this practical approach to maximizing profits means examining how changes in production affect marginal revenue and marginal cost. Figure 8.3 presents the marginal revenue and marginal cost curves based on the total revenue and total cost in Table 8.1. The marginal revenue curve shows the additional revenue gained from selling one more unit. As mentioned before, a firm in perfect competition faces a perfectly elastic demand curve for its product. That is, the firm's demand curve is a horizontal line drawn at the market price level. This also means that the firm's marginal revenue curve is the same as the firm's demand curve. Every time a consumer demands one more unit, the firm sells one more unit, and revenue increases by exactly the same amount equal to the market price. In this example, every time the firm sells a pack of frozen raspberries, the firm's revenue increases by $4. Table 8.2 shows an example of this. This condition only holds for price-taking firms in perfect competition where marginal revenue equals price. The formula for marginal revenue is marginal revenue equals change in total revenue chain. In quantity price quantity total, revenue marginal revenue, for $1 $4, for $2 $8 $4, for $3 $12 $4, for $4 $16 $4. Table 8. To notice that marginal revenue does not change as the firm produces more output. That is because, under perfect competition, the price is determined through the interaction of supply and demand in the market, and does not change as the farmer produces more, keeping in mind that, due to the relative small size of each firm, increasing their supply has no impact on the total market supply where price is determined. Since a perfectly competitive firm is a price taker, it can sell whatever quantity it wishes at the market-determined price. We calculate marginal cost, the cost per additional unit sold, by dividing the change in total cost by the change in quantity. The formula for marginal cost is marginal cost equals change in total cost. Change in quantity. Ordinarily, marginal cost changes as the firm produces a greater quantity. In the raspberry farm example, in Figure 8.3 and Table 8.3, marginal cost at first declines as production increases from 10 to 20 to 30 to 40 packs of raspberries, which represents the area of increasing marginal returns that is not uncommon at low levels of production. At some point, though, marginal costs start to increase, displaying the typical pattern of diminishing marginal returns. If the firm is producing at a quantity where Mr. MC, like 40 or 50 packs of raspberries, then it can increase profit by increasing output because the marginal revenue is exceeding the marginal cost. If the firm is producing at a quantity where MC Mr., like 90 or 100 packs, then it can increase profit by reducing output because the reductions in marginal cost will exceed the reductions in marginal revenue. The firm's profit-maximizing choice of output will occur where Mr. equals MC, or at a choice close to that point. This graph illustrates marginal revenue and marginal cost curves of an individual farmer in a perfectly competitive market. The y-axis shows marginal cost and marginal revenue measured in dollars. The x-axis shows quantity as packs of raspberries. The marginal revenue curve is shown as a straight horizontal line at $5 because, in a perfectly competitive market, price is determined by the market, and that price is marginal revenue. The marginal cost curve starts just below marginal revenue, decreases, then begins to increase after quantity of 50. As marginal cost is increasing, it intersects marginal revenue at a quantity of 80, and this is identified as the profit maximizing point. Figure 8. 3 marginal revenues and marginal costs at the raspberry farm. Individual farmer for a perfectly competitive firm. The marginal revenue, Mr. curve, is a horizontal line because it is equal to the price of the good, which is determined by the market, as Figure 8. 4 illustrates. The marginal cost, MC, curve is sometimes initially downward sloping if there is a region of increasing marginal returns at low levels of output, but is eventually upward sloping at higher levels of output as diminishing marginal returns kick in. This graph illustrates the market for raspberries. There is a downward sloping demand curve and an upward sloping supply curve. Equilibrium is shown at a price of $4 and a quantity of 800 raspberry packs. Figure 8. 4 supply, demand, and equilibrium price. In the market for raspberries, the equilibrium price of raspberries is determined through the interaction of market supply and market demand at $4. If there are 10 farms in the market, the equilibrium quantity is 80 times 10 equals 800. Quantity total cost marginal cost total revenue marginal revenue profit 0 $62 $0 $4 $62 $10 $90 $2 $80 $40 $4 $50 $20 $110 $2 $80 $4 $30 $30 $126 $1 $60 $120 $4 $640 $138 $1 $20 $160 $4 $2250 $150 $1 $2,200 $4 $50 $60 $165 $1 $50 $240 $4 $75 $70 $190 $2 $50 $280 $4 $90 $80 $230 $4 $320 $4 $90 $90 $296 $6 $6,360 $4 $64 $100 $400 $10 $40 $400 $4 0 $110 $550 $15 $440 $4 $110 $120 $715 $16 $50 $480 $4 $235 Table 8. 3 marginal revenues and marginal costs at the raspberry farm in this example. The marginal revenue and marginal cost curves cross at a price of $4 and a quantity of 80 produced. If the farmer started out producing at a level of 60 and then experimented with increasing production to 70, marginal revenues from the increase in production would exceed marginal costs, and so profits would rise. The farmer has an incentive to keep producing. At a level of output of 80, marginal cost and marginal revenue are equal, so profit doesn't change. If the farmer then experimented further with increasing production from 80 to 90, he would find that marginal costs from the increase in production are greater than marginal revenues, and so profits would decline. The profit-maximizing choice for a perfectly competitive firm will occur at the level of output where marginal revenue is equal to marginal cost, that is, where Mr. equals MC. This occurs at Q equals 80 in the figure. Work it out. Does profit maximization occur at a range of output or a specific level of output? Table 8. 1 shows that maximum profit occurs at any output level between 70 and 80 units of output. But Mr. equals MC occurs only at 80 units of output. How can we explain this slight discrepancy? As long as Mr. MC, a profit-seeking firm should keep expanding production. Expanding production into the zone where Mr. MC reduces economic profits. It's true that profit is the same at Q equals 70 and Q equals 80, but it's only when the firm goes beyond that Q that it will see that profits fall. Thus, Mr. equals MC is the signal to stop expanding, so that is the level of output they should target. Because the marginal revenue received by a perfectly competitive firm is equal to the price P, we can also write the profit-maximizing rule for a perfectly competitive firm as a recommendation to produce at the quantity of output where P equals MC. Profits and losses with the average cost curve does maximizing profit, producing where Mr. equals MC, imply an actual economic profit. The answer depends on the relationship between price and average total cost, which is the average profit or profit margin. If the market price is higher than the firm's average cost of production for that quantity produced, then the profit margin is positive and the firm will earn profits. Conversely, if the market price is lower than the average cost of production, the profit margin is negative and the firm will suffer losses. You might think that, in this situation, the firm may want to shut down immediately. Remember, however, that the firm has already paid for fixed costs, such as equipment, so it may continue to produce for a while and incur a loss. Table 8.3 continues the raspberry farm example. Figure 8.5 illustrates the three possible scenarios. A, where price intersects marginal cost at a level above the average cost curve. B, where price intersects marginal cost at a level equal to the average cost curve, and C, where price intersects marginal cost at a level below the average cost curve. Three graphs are illustrated. The first one, A, shows U-shaped average cost combined with a marginal cost curve that first decreases, then increases and intersects average cost at the minimum average cost. A horizontal line shows the market price of raspberries at $5. This is also marginal revenue, and it is shown intersecting the marginal cost curve at a quantity of 85 packs of raspberries, which is the profit-maximizing amount of output. This intersection is labeled E, and a vertical line is drawn down from it to the quantity axis. This vertical line intersects the average cost curve at a point labeled C. A blue shaded rectangle is created showing positive profits at this price of raspberries. The next graph, B, shows the break-even point. Average cost and marginal cost are drawn the same, but the market price is now $3, which is also marginal revenue. This marginal revenue line intersects marginal cost at minimum average cost, at a point labeled E, and the profit-maximizing quantity of raspberries is shown as 70 packs. Because marginal revenue and average cost are equal, there is no profit or loss. The last graph, C, shows loss. Average cost and marginal cost are drawn the same, but the market price is now $2, which is also marginal revenue. This marginal revenue line intersects marginal cost at point labeled E, which is below average cost. A vertical line is drawn up from this point to average cost, and that intersection is labeled C. The vertical distance E to C represents the per unit loss of producing this amount of raspberries, 65 packs. A red shaded rectangle is created showing the loss. Figure 8.5 price and average cost at the raspberry farm in A. Price intersects marginal cost above the average cost curve. Since price is greater than average cost, the firm is making a profit. In B, price intersects marginal cost at the minimum point of the average cost curve. Since price is equal to average cost, the firm is breaking even. In C, price intersects marginal cost below the average cost curve. Since price is less than average cost, the firm is making a loss. First, consider a situation where the price is equal to $5 for a pack of frozen raspberries. The rule for a profit-maximizing perfectly competitive firm is to produce the level of output where price equals Mr. equals MC. So the raspberry farmer will produce a quantity of approximately 85, which is labeled as E in Figure 8.5a. Remember that the area of a rectangle is equal to its base multiplied by its height. The farm's total revenue at this price will be shown by the rectangle from the origin over to a quantity of 85 packs, the base, up to point E, the height, over to the price of $5 and back to the origin. The average cost of producing 85 packs is shown by point C, or about $3.09. Total costs will be the quantity of 85 times the average cost of $3.09, which is shown by the area of the rectangle from the origin to a quantity of 85, up to point C, over to the vertical axis and down to the origin. The difference between total revenues and total costs is profits. Thus, profits will be the blue shaded rectangle on top. We calculate this as profit equals total revenue minus total cost, $85.500 minus $85.309 or we can calculate it as profit equals price average cost times quantity $5.0039 times $85.162.35. Now consider figure 85b, where the price has fallen to $2.80 for a pack of frozen raspberries. Again, the perfectly competitive firm will choose the level of output where price equals Mr. equals MC. But in this case, the quantity produced will be 75. At this price and output level, where the marginal cost curve is crossing the average cost curve, the price the firm receives is exactly equal to its average cost of production. We call this the break-even point. The farm's total revenue at this price can be shown by the rectangle from the origin over to a quantity of 75 packs, the base, up to point E, the height, over to the price of $2.80, and back to the origin. The height of the average cost curve at Q equals 75, i.e. point E, shows the average cost of producing this quantity. Total costs will be the quantity of 75 times the average cost of $2.80, which is shown by the area of the rectangle from the origin to a quantity of 75, up to point E, over to the vertical axis, and down to the origin. It should be clear that the rectangles for total revenue and total cost are the same. This is also why these two rectangles are not shaded in figure 85b. Thus, the firm is making zero profit. The calculations are as follows. Profit equals total revenue, total cost $75.2, $80, $75.2, $80.0, or we can calculate it as profit equals price, average cost, times quantity $2, $80.2, 80 times $75.0 in figure 85C. The market price has fallen still further to $2 for a pack of frozen raspberries. At this price, marginal revenue intersects marginal cost at a quantity of 65. The farm's total revenue at this price will be shown by the large shaded rectangle from the origin over to a quantity of 65 packs, the base, up to point E, the height, over to the price of $2 and back to the origin. The average cost of producing 65 packs is shown by point C, or shows the average cost of producing 50 packs is about $2, $73. Total costs will be the quantity of 65 times the average cost of $2.73, which the area of the rectangle from the origin to a quantity of 50, up to point C, over to the vertical axis and down to the origin shows. It should be clear from examining the two rectangles that total revenue is less than total cost. Thus, the firm is losing money and the loss or negative profit will be the rose-shaded rectangle. The calculations are profit equals total revenue total cost $65.2, $65.2, $73.47.45, or profit equals price average cost times quantity $2, $0.2, 73 times $65.47. 45. If the market price that perfectly competitive firm receives leads it to produce at a quantity where the price is greater than average cost, the firm will earn profits. If the price the firm receives causes it to produce at a quantity where price equals average cost, which occurs at the minimum point of the AC curve, then the firm earns zero profits. Finally, if the price the firm receives leads it to produce at a quantity where the price is less than average cost, the firm will earn losses. Table 8.4 summarizes this. If, then, price ATC firm earns an economic profit price equals ATC firm earns zero economic profit price, ATC firm earns a loss. Table 8.4 clear it up. Which intersection should a firm choose? At a price of $2, Mr. intersects MC at 2 points. Q equals 20 and Q equals 65. It never makes sense for a firm to choose a level of output on the downward sloping part of the MC curve, because the profit is lower, the loss is bigger. Thus, the correct choice of output is Q equals 65. The shutdown point, the possibility that a firm may earn losses, raises a question. Why can the firm not avoid losses by shutting down and not producing at all? The answer is that shutting down can reduce variable costs to zero, but in the short run, the firm has already paid for fixed costs. As a result, if the firm produces a quantity of zero, it would still make losses because it would still need to pay for its fixed costs. Therefore, when a firm is experiencing losses, it must face a question. Should it continue producing or should it shut down? As an example, consider the situation of the yoga center, which has signed a contract to rent space that costs $10,000 per month. If the firm decides to operate, its marginal costs for hiring yoga teachers is $15,000 for the month. If the firm shuts down, it must still pay the rent, but it would not need to hire labor. Table 8.5 shows 3 possible scenarios. In the first scenario, the yoga center does not have any clients and therefore does not make any revenues, in which case it faces losses of $10,000 equal to the fixed costs. In the second scenario, the yoga center has clients that earn the center revenues of $10,000 for the month, but ultimately experiences losses of $15,000 due to having to hire yoga instructors to cover the classes. In the third scenario, the yoga center earns revenues of $20,000 for the month, but experiences losses of $5,000. In all 3 cases, the yoga center loses money. In all 3 cases, when the rental contract expires in the long run, assuming revenues do not improve, the firm should exit this business. In the short run, though, the decision varies depending on the level of losses and whether the firm can cover its variable costs. In Scenario 1, the center does not have any revenues, so hiring yoga teachers would increase variable costs and losses, so it should shut down and only incur its fixed costs. In Scenario 2, the center's losses are greater because it does not make enough revenue to offset the increased variable costs, so it should shut down immediately and only incur its fixed costs. If price is below the minimum average variable cost, the firm must shut down. In contrast, in Scenario 3, the revenue that the center can earn is high enough that the losses diminish when it remains open, so the center should remain open in the short run. Scenario 1, if the center shuts down now, revenues are zero, but it will not incur any variable costs and would only need to pay fixed costs of $10,000. Profit equals total revenue. Fixed costs plus variable cost equals zero. $10,000 equals $10,000. Scenario 2, the center earns revenues of $10,000 and variable costs are $15,000. The center should shut down now. Profit equals total revenue. Fixed costs plus variable cost equals $10,000. $10,000 plus $15,000 equals $15,000. Scenario 3, the center earns revenues of $20,000 and variable costs are $15,000. The center should continue in business. Profit equals total revenue. Fixed costs plus variable cost equals $20,000. $10,000 plus $15,000 equals $5,000. Table 8. 5. Should the yoga center shut down now or later? Figure 8. 6 illustrates the lesson that remaining open requires the price to exceed the firm's average variable cost. When the firm is operating below the break-even point, where price equals average cost, it is operating at a loss, so it faces two options: continue to produce and lose money, or shut down. Which option is preferable? The one that loses the least money is the best choice. At a price of $2 per pack, as Figure 8. 6 illustrates, if the farm stays in operation, it will produce at a level of 65 packs of raspberries, and it will make losses of $47.45, as explained earlier. The alternative would be to shut down and lose all the fixed costs of $62. Since losing $47.45 is preferable to losing $62. 0. The profit maximizing, or in this case, the loss minimizing choice, is to stay in operation. The key reason is because price is above average variable cost. This means that at the current price the farm can pay all its variable costs and have some revenue left over to pay some of the fixed costs. So the loss represents the part of the fixed costs the farm can't pay, which is less than the entire fixed costs. However, if the price declined to $1.50 per pack, as Figure 8. 6b shows, and if the firm applied its rule of producing where P equals Mr equals MC, it would produce a quantity of 60. This price is below average variable cost for this level of output. If the farmer cannot pay workers the variable costs, then it has to shut down. At this price and output, total revenues would be $90, quantity of 60 times price of $1.50, and total cost would be $165, for overall losses of $75. If the farm shuts down, it must pay only its fixed costs of $62, so shutting down is preferable to selling at a price of $1.50 per pack. The graphs show that despite negative profits, i.e. losses, firms can continue to operate. However, when prices drop beneath variable cost, firms will shut down. Figure 8. 6. The shutdown point for the raspberry farm in A. The farm produces at a level of 65. It is making losses of $47.50, but price is above average variable cost, so it continues to operate. In B, total revenues are $90 and total cost is $165, for overall losses of $75. If the farm shuts down, it must pay only its fixed costs of $62. Shutting down is preferable to selling at a price of $1.50 per pack. Looking at Table 8.6, if the price falls below about $1.72, the minimum average variable cost, the firm must shut down. Quantity Q average variable cost AVC average cost AC marginal cost MC 10 $2, $80 $9 $2, 80 $20 $2, $40 $5, $50 $2, $32 13 $4 $21, 60 $40 $1, $90 $3, $45 $1, 20 $50 $1, $76 $3 $1, 20 $61, $72 $2, $75 $1, 50 $70 $180 $2, $71 $2, 50 $80 $2, $10 $2, $88 $4, $92, $60 $3, $29 $6, $6,100 $3, $38 $4, $10, $4,110 $4, $44 $5, $15, $120 $5, $44 $5, $96 $31, $50. Table 8. 6. Cost of production for the raspberry farm, the intersection of the average variable cost curve and the marginal cost curve, which shows the price below which the firm would lack enough revenue to cover its variable costs, is called the shutdown point. If the perfectly competitive firm faces a market price above the shutdown point, then the firm is at least covering its average variable costs. At a price above the shutdown point, the firm is also making enough revenue to cover at least a portion of fixed costs, so it should limp ahead even if it is making losses in the short run, since at least those losses will be smaller than if the firm shuts down immediately and incurs a loss equal to total fixed costs. However, if the firm is receiving a price below the price at the shutdown point, then the firm is not even covering its variable costs. In this case, staying open is making the firm's losses larger, and it should shut down immediately. To summarize, if price minimum average variable cost, then firm shuts down price minimum average variable cost, then firm stays in business. Short-run outcomes for perfectly competitive firms: the average cost and average variable cost curves divide the marginal cost curve into 3 segments, as Figure 8.7 shows. At the market price, which the perfectly competitive firm accepts as given, the profit-maximizing firm chooses the output level where price or marginal revenue, which are the same thing for a perfectly competitive firm, is equal to marginal cost. P equals Mr equals MC. The graph shows how the marginal cost curve reveals 3 different zones: above the zero profit point, between the zero profit point and the shutdown point, and below the shutdown point. Figure 8.7 profit, loss, shutdown. We can divide the marginal cost curve into 3 zones, based on where it is crossed by the average cost and average variable cost curves. We call the point where MC crosses AC the break-even point. If the firm is operating where the market price is at a level higher than the break-even point, then price will be greater than average cost, and the firm is earning profits. If the price is exactly at the break-even point, then the firm is making 0 profits. If price falls in the zone between the shutdown point and the break-even point, then the firm is making losses but will continue to operate in the short run, since it is covering its variable costs, and more if price is above the shutdown point price. However, if price falls below the price at the shutdown point, then the firm will shut down immediately, since it is not even covering its variable costs. First, consider the upper zone, where prices are above the level where marginal cost, MC, crosses average cost, AC, at the 0 profit point. At any price above that level, the firm will earn profits in the short run. If the price falls exactly on the break-even point where the MC and AC curves cross, then the firm earns 0 profits. If a price falls into the zone between the break-even point, where MC crosses AC, and the shutdown point, where MC crosses AVC, the firm will be making losses in the short run. But since the firm is more than covering its variable costs, the losses are smaller than if the firm shut down immediately. Finally, consider a price at or below the shutdown point where MC crosses AVC. At any price like this one, the firm will shut down immediately, because it cannot even cover its variable costs. Marginal cost and the firm's supply curve for a perfectly competitive firm. The marginal cost curve is identical to the firm's supply curve, starting from the minimum point on the average variable cost curve. To understand why this perhaps surprising insight holds true, first think about what the supply curve means. A firm checks the market price and then looks at its supply curve to decide what quantity to produce. Now, think about what it means to say that a firm will maximize its profits by producing at the quantity where P equals MC. This rule means that the firm checks the market price and then looks at its marginal cost to determine the quantity to produce, and makes sure that the price is greater than the minimum average variable cost. In other words, the marginal cost curve above the minimum point on the average variable cost curve becomes the firm's supply curve. Link it up. Watch this video that addresses how drought in the United States can impact food prices across the world. As we discussed in the chapter on demand and supply, many of the reasons that supply curves shift relate to underlying changes in costs. For example, a lower price of key inputs or new technologies that reduce production costs cause supply to shift to the right. In contrast, bad weather or added government regulations can add to costs of certain goods in a way that causes supply to shift to the left. We can also interpret these shifts in the firm's supply curve as shifts of the marginal cost curve. A shift in costs of production that increases marginal costs at all levels of output and shifts MC upward and to the left will cause a perfectly competitive firm to produce less at any given market price. Conversely, a shift in costs of production that decreases marginal costs at all levels of output will shift MC downward and to the right, and as a result, a competitive firm will choose to expand its level of output at any given price. The following Work It Out feature will walk you through an example. Work it out at what price should the firm continue producing in the short run. To determine the short-run economic condition of a firm in perfect competition, follow the steps outlined below. Use the data in Table 8, 7. QP TFC TVC TC AVC ATC MCTR profits $0 $28 $20 $0 $1 $28 $20 $20 $2 $28 $20 $25 $3 $28 $20 $35 $4 $28 $20 $52 $5 $28 $20 $80. Table 8. 7. Step 1. Determine the cost structure for the firm. For a given total fixed costs and variable costs, calculate total cost, average variable cost, average total cost, and marginal cost. Follow the formulas given in the production, costs, and industry structure chapter. These calculations are in Table 8.8. QP TFC TVC TC, TFC plus TVC, AVC TVCQ, ATC TCQ, MC TC2 minus TC1 slash Q2 minus Q1 $0, $28 $20 $0 20 plus $0 equals $20. $1 $28 $20 $20 20 plus $20 equals $40 20 slash 1 equals $20. 40 slash 1 equals $40. $0 40 minus $20 slash 1 minus 0 equals $22 $28 $20 $25 20 plus $25 equals $40. 5 25 slash 2 equals $12. 50 45 slash 2 equals $22. $50 45 minus $40 slash 2 minus 1 equals $5 $3 $28 $20 $35 20 plus $35 equals $55 35 slash 3 equals $11. 67 55 slash 3 equals $18. $33 55 minus $45 slash 3 minus 2 equals $10 $4 $28 $20 $52 20 plus $52 equals $72 52 slash 4 equals $13. 72 slash 4 equals $18. 72 minus $55 slash 4 minus 3 equals $17 $5 $28 $20 $80 20 plus $80 equals $180 slash 5 equals $16. 100 slash 5 equals $20. $0 100 minus $72 slash 5 minus 4 equals $28. Table 8. 8. Step 2. Determine the market price that the firm receives for its product. Since the firm in perfect competition is a price taker, the market price is constant. With the given price, calculate total revenue as equal to price multiplied by quantity for all output levels produced. In this example, the given price is $28. You can see that in the second column of Table 8. 9. Quantity price total revenue. P times Q, 0, $28 28 times 0 equals $0. $128, 28 times 1 equals $28 $2, $28, 28 times 2 equals $56 $3, $28, 28 times 3 equals $80 $4 $28, 28 times 4 equals $112 $5, $28, 28 times 5 equals $140. Table 8. 9. Step 3. Calculate profits as total costs subtracted from total revenue, as Table 8. 10 shows. Quantity total, revenue total, cost profits. TR minus TC $00 $20 0 minus $20 equals minus $21 $28 $40 28 minus $40 equals minus $12 $2 $56 $45 56 minus $45 equals $11 $3 $84 $55 84 minus $55 equals $29 $4 $112 $72 $112 minus $72 equals $45 $140 $100 140 minus $100 equals $40. Table 8. 10. Step 4. To find the profit maximizing output level, look at the marginal cost column at every output level produced, as Table 8. 11 shows, and determine where it is equal to the market price. The output level where price equals the marginal cost is the output level that maximizes profits. QP, TFC, TVC, TC, AVC, ATC, MCTR profits 0, $28, $20, $0, $20, $0 minus $21, $28, $20, $20, $40, $20, $40, $20, $28 minus $12 $2, $28, $20, $25, $45, $12, $50, $22, $55, $56, $11 $3, $28, $20, $35, $55, $11, $67, $18, $33 $10, $84, $29, $4, $28, $20, $52, $72, $13, $18, $17, $112, $45, $28, $20, $80, $100, $16, $20, $28, $140, $40. Table 8. 11. Step 5. Once you have determined the profit maximizing output level, in this case, output quantity 5, you can look at the amount of profits made, in this case, $40. Step 6. If the firm is making economic losses, the firm needs to determine whether it produces the output level where price equals marginal revenue and equals marginal cost, or it shuts down and only incurs its fixed costs. Step 7. For the output level where marginal revenue is equal to marginal cost, check if the market price is greater than the average variable cost of producing that output level. If PAVC but PATC, then the firm continues to produce in the short run, making economic losses. If PAVC, then the firm stops producing and only incurs its fixed costs. In this example, the price of $28 is greater than the AVC, $16, $40 of producing 5 units of output, so the firm continues producing. Learning objectives. By the end of this section, you will be able to explain how entry and exit lead to zero profits in the long run, discuss the long-run adjustment process. It is impossible to precisely define the line between the short run and the long run with a stopwatch, or even with a calendar. It varies according to the specific business. Therefore, the distinction between the short run and the long run is more technical. In the short run, firms cannot change the usage of fixed inputs, while in the long run, the firm can adjust all factors of production. In a competitive market, profits are a red cape that incites businesses to charge. If a business is making a profit in the short run, it has an incentive to expand existing factories or to build new ones. New firms may start production as well. When new firms enter the industry in response to increased industry profits, it is called entry. Losses are the black thundercloud that causes businesses to flee. If a business is making losses in the short run, it will either keep limping along or just shut down, depending on whether its revenues are covering its variable costs. But in the long run, firms that are facing losses will cease production altogether. The long-run process of reducing production in response to a sustained pattern of losses is called exit. The following Clear It Up feature discusses where some of these losses might come from and the reasons why some firms go out of business. Clear it up. Why do firms cease to exist? Can we say anything about what causes a firm to exit an industry? Profits are the measurement that determines whether a business stays operating or not. Individuals start businesses with the purpose of making profits. They invest their money, time, effort, and many other resources to produce and sell something that they hope will give them something in return. Unfortunately, not all businesses are successful, and many new startups soon realize that their business venture must eventually end. In the model of perfectly competitive firms, those that consistently cannot make money will exit, which is a nice, bloodless word for a more painful process. When a business fails, after all, workers lose their jobs, investors lose their money, and owners and managers can lose their dreams. Many businesses fail. The U.S. Small Business Administration indicates that in 2011, 534,907 new firms entered, and 575,691 firms failed. Sometimes a business fails because of poor management or workers who are not very productive, or because of tough domestic or foreign competition. Businesses also fail from a variety of causes. For example, conditions of demand and supply in the market may shift in an unexpected way, so that the prices that a business charges for outputs fall or the prices for inputs rise. With millions of businesses in the U.S. economy, even a small fraction of them failing will affect many people, and business failures can be very hard on the workers and managers directly involved. However, from the standpoint of the overall economic system, business exits are sometimes a necessary evil if a market-oriented system is going to offer a flexible mechanism for satisfying customers, keeping costs low, and inventing new products. How entry and exit lead to zero profits in the long run. No perfectly competitive firm acting alone can affect the market price. However, the combination of many firms entering or exiting the market will affect overall supply in the market. In turn, a shift in supply for the market as a whole will affect the market price. Entry and exit to and from the market are the driving forces behind a process that, in the long run, pushes the price down to minimum average total costs so that all firms are earning a zero profit. To understand how short-run profits for a perfectly competitive firm will evaporate in the long run, imagine the following situation. The market is in long-run equilibrium, where all firms earn zero economic profits, producing the output level where P equals Mr equals MC and P equals AC. No firm has the incentive to enter or leave the market. Let's say that the product's demand increases, and with that, the market price goes up. The existing firms in the industry are now facing a higher price than before, so they will increase production to the new output level where P equals Mr equals MC. This will temporarily make the market price rise above the minimum point on the average cost curve, and therefore, the existing firms in the market will now be earning economic profits. However, these economic profits attract other firms to enter the market. Entry of many new firms causes the market supply curve to shift to the right. As the supply curve shifts to the right, the market price starts decreasing, and with that, economic profits fall for new and existing firms. As long as there are still profits in the market, entry will continue to shift supply to the right. This will stop whenever the market price is driven down to the zero profit level, where no firm is earning economic profits. Short-run losses will fade away by reversing this process. Say that the market is in long-run equilibrium. This time, instead, demand decreases, and with that, the market price starts falling. The existing firms in the industry are now facing a lower price than before, and as it will be below the average cost curve, they will now be making economic losses. Some firms will continue producing where the new P equals Mr. equals MC, as long as they are able to cover their average variable costs. Some firms will have to shut down immediately as they will not be able to cover their average variable costs, and will then only incur their fixed costs, minimizing their losses. Exit of many firms causes the market supply curve to shift to the left. As the supply curve shifts to the left, the market price starts rising, and economic losses start to be lower. This process ends whenever the market price rises to the zero profit level, where the existing firms are no longer losing money and are at zero profits again. Thus, while a perfectly competitive firm can earn profits in the short run, in the long run the process of entry will push down prices until they reach the zero profit level. Conversely, while a perfectly competitive firm may earn losses in the short run, firms will not continually lose money. In the long run, firms making losses are able to escape from their fixed costs, and their exit from the market will push the price back up to the zero profit level. In the long run, this process of entry and exit will drive the price in perfectly competitive markets to the zero profit point at the bottom of the AC curve, where marginal cost crosses average cost. The long-run adjustment and industry types whenever there are expansions in an industry. Costs of production for the existing and new firms could either stay the same, increase, or even decrease. Therefore, we can categorize an industry as being 1. A constant cost industry. As demand increases, the cost of production for firms stays the same. 2. An increasing cost industry. As demand increases, the cost of production for firms increases. Or 3. A decreasing cost industry. As demand increases, the costs of production for the firms decreases. For a constant cost industry, whenever there is an increase in market demand and price, then the supply curve shifts to the right with new firms' entry and stops at the point where the new long-run equilibrium intersects at the same market price as before. This is the case of constant returns to scale, which we discussed earlier in the chapter on production, costs, and industry structure. However, why will costs remain the same? In this type of industry, the supply curve is very elastic. Firms can easily supply any quantity that consumers demand. In addition, there is a perfectly elastic supply of inputs. Firms can easily increase their demand for employees, for example, with no increase to wages. Tying into our Bring It Home discussion, an increased demand for ethanol in recent years has caused the demand for corn to increase. Consequently, many farmers switched from growing wheat to growing corn. Agricultural markets are generally good examples of constant cost industries. For an increasing cost industry, as the market expands, the old and new firms experience increases in their costs of production, which makes the new zero profit level intersect at a higher price than before. Here companies may have to deal with limited inputs, such as skilled labor. As the demand for these workers rises, wages rise, and this increases the cost of production for all firms. The industry supply curve in this type of industry is more inelastic. For a decreasing cost industry, as the market expands, the old and new firms experience lower costs of production, which makes the new zero profit level intersect at a lower price than before. In this case, the industry and all the firms in it are experiencing falling average total costs. This can be due to an improvement in technology in the entire industry or an increase in the education of employees. High-tech industries may be a good example of a decreasing cost market. Figure 8.8a presents the case of an adjustment process in a constant cost industry. Whenever there are output expansions in this type of industry, The long-run outcome implies more output produced at exactly the same original price. Note that supply was able to increase to meet the increased demand. When we join the before and after long-run equilibriums, the resulting line is the long-run supply (LRS) curve in perfectly competitive markets. In this case, it is a flat curve. Figure 8.8b and Figure 8.8c present the cases for an increasing cost and decreasing cost industry, respectively. For an increasing cost industry, the LRS is upward sloping, while for a decreasing cost industry, the LRS is downward sloping. These three graphs show that the LRS is constant when costs do not increase or decrease. LRS slopes upward when costs are increasing, and LRS slopes downward when costs are decreasing. Figure 8. Adjustment process in a constant cost industry in A. Demand increased and supply met it. Notice that the supply increase is equal to the demand increase. The result is that the equilibrium price stays the same as quantity sold increases. In B, notice that sellers were not able to increase supply as much as demand. Some inputs were scarce or wages were rising. The equilibrium price rises. In C, sellers easily increased supply in response to the demand increase. Here, new technology or economies of scale caused the large increase in supply, resulting in declining equilibrium price. Learning objectives. By the end of this section, you will be able to apply concepts of productive efficiency and allocative efficiency to perfectly competitive markets. Compare the model of perfect competition to real-world markets. When profit-maximizing firms in perfectly competitive markets combine with utility-maximizing consumers, something remarkable happens. The resulting quantities of outputs of goods and services demonstrate both productive and allocative efficiency, terms that we first introduced in choice in a world of scarcity. Productive efficiency means producing without waste, so that the choice is on the production possibility frontier. In the long run, in a perfectly competitive market, because of the process of entry and exit, the price in the market is equal to the minimum of the long-run average cost curve. In other words, firms produce and sell goods at the lowest possible average cost. Allocative efficiency means that among the points on the production possibility frontier, the chosen point is socially preferred, at least in a particular and specific sense. In a perfectly competitive market, price will be equal to the marginal cost of production. Think about the price that one pays for a good as a measure of the social benefit one receives for that good. After all, willingness to pay conveys what the good is worth to a buyer. Then think about the marginal cost of producing the good as representing not just the cost for the firm, but more broadly as the social cost of producing that good. When perfectly competitive firms follow the rule that profits are maximized by producing at the quantity where price is equal to marginal cost, they are thus ensuring that the social benefits they receive from producing a good are in line with the social costs of production. To explore what economists mean by allocative efficiency, it is useful to walk through an example. Begin by assuming that the market for wholesale flowers is perfectly competitive, and so P equals MC. Now consider what it would mean if firms in that market produced a lesser quantity of flowers. At a lesser quantity, marginal costs will not yet have increased as much, so that price will exceed marginal cost, that is, PMC. In that situation, the benefit to society as a whole of producing additional goods, as measured by the willingness of consumers to pay for marginal units of a good, would be higher than the cost of the inputs of labor and physical capital needed to produce the marginal good. In other words, the gains to society as a whole from producing additional marginal units will be greater than the costs. Conversely, consider what it would mean if, compared to the level of output at the allocatively efficient choice when P equals MC, firms produced a greater quantity of flowers. At a greater quantity, marginal costs of production will have increased so that PMC. In that case, the marginal costs of producing additional flowers is greater than the benefit to society as measured by what people are willing to pay. For society as a whole, since the costs are outstripping the benefits, it will make sense to produce a lower quantity of such goods. When perfectly competitive firms maximize their profits by producing the quantity where P equals MC, they also assure that the benefits to consumers of what they are buying, as measured by the price they are willing to pay, is equal to the costs to society of producing the marginal units, as measured by the marginal costs the firm must pay, and thus that allocative efficiency holds. We should view the statements that a perfectly competitive market in the long run will feature both productive and allocative efficiency with a degree of skepticism about its truth. Remember, economists are using the concept of efficiency in a particular and specific sense, not as a synonym for desirable in every way. For one thing, consumers' ability to pay reflects the income distribution in a particular society. For example, a person with a low income may not be able to purchase their own car because they have insufficient income. Perfect competition, in the long run, is a hypothetical benchmark. For market structures such as monopoly, monopolistic competition, and oligopoly, which are more frequently observed in the real world than perfect competition, firms will not always produce at the minimum of average cost, nor will they always set price equal to marginal cost. Thus, these other competitive situations will not produce productive and allocative efficiency. Moreover, real-world markets include many issues that are assumed away in the model of perfect competition, including pollution, inventions of new technology, poverty which may make some people unable to pay for basic necessities of life, government programs like national defense or education, discrimination in labor markets, and buyers and sellers who must deal with imperfect and unclear information. We explore these issues in other chapters. However, the theoretical efficiency of perfect competition does provide a useful benchmark for comparing the issues that arise from these real-world problems. Bring it home. A dime a dozen. A quick glance at Table 8:12 reveals the dramatic increase in North Dakota corn production, almost a tenfold increase since 1972. Recent allocation of land to corn, as of mid-2019, is estimated to have increased to more than 4 million acres. Taking into consideration that corn typically yields 2 to 3 times as many bushels per acre as wheat, it is obvious there has been a significant increase in bushels of corn. Why the increase in corn acreage? Converging prices. Year corn millions of acres. 1972, 495, 000. 2013, 3, 850, 000. Table 812 source. USDA, National Agricultural Statistics Service. Historically, wheat prices have been higher than corn prices, offsetting wheat's lower yield per acre. However, in recent years wheat and corn prices have been converging. In April 2013, AgWeek reported the gap was just 71 cents per bushel. As the difference in price narrowed, switching to the production of higher yield per acre of corn simply made good business sense. Eric Youngren, president of the National Association of Wheat Growers, said in the AgWeek article, "I don't think we're going to see mile after mile of waving amber fields of wheat anymore. Until wheat prices rise, we will probably be seeing field after field of tasseled corn,